In this video, I'm going to talk about writing ionic equations for a special type of double replacement reaction, which is going to be called either an acid-base reaction or a neutralization reaction. It has both terms. In this kind of reaction, we have an acid like HCl. You would know it's an acid because it's going to have an H there in the front. That makes it an acid. And maybe it's going to be combined with some kind of base. So for example, sodium hydroxide is a base. How do I know that's a base? Because it ends in OH. So the acids are going to have an H here at the front, and a base is going to have OH. There are other kinds of bases, but this is what we're going to talk about in our course. So let's make it a little bit more complex. Let's take H2SO4. It has to be aqueous because we're talking about double replacement reaction here. And we're going to combine it with calcium hydroxide, which is also aqueous. I know that calcium hydroxide is mostly insoluble in water, but you can get some to dissolve. So you can have an aqueous solution of calcium hydroxide. So if we're going to predict the products, it's a double replacement reaction. So the SO4 and the calcium are going to be written together. Calcium is +2. Sulfate is -2, so we just need one of each. And if we use our solubility table, we can confirm that this is aqueous. And I'm running out of room here. I'm also going to make hydrogen, and then the OH are going to go together, HOH. And then hopefully you can recognize that that is water, and that's going to be liquid. So I'm going to rewrite this so it's not written off the page. So we have H2SO4 aqueous plus calcium hydroxide aqueous produces calcium sulfate aqueous plus water, which is going to be a liquid. I'm not going to balance this. I know that it's not balanced. I'm not going to balance it right now. Okay, when we're writing ionic equations, that's the whole point of this. So we're going to start out with the total or the complete ionic equation where we write everything that's involved here. So remember, with an ionic equation, every time you see aqueous, that's telling you this does not really exist in solution. They have separated. So what is this made out of? Well, this is H+. It is not H2. I don't care that I have two of these. This right here was made from H+ and SO4 2-. The only reason I have a 2 here is because I need 2 hydrides for every one of those. But all we're doing in our ionic equation is identifying what ions we have. So we have that, which is aqueous. Has to be aqueous because that's aqueous. We have the sulfate ion, which is aqueous, plus the calcium ion, which is aqueous, the hydroxide ion, OH-, which is aqueous. It's going to produce calcium, which is aqueous, the sulfate again, which is aqueous, and then this is not aqueous, it's a liquid, so it's going to stay together. H2O, and then O. So when we have this total ionic equation, we're going to eliminate everything that's the same on both sides to come up with our net ionic equation. So our net ionic equation for any acid-base reaction where we have an acid and a base mixed together, what do we have left? Well, we have H+, which is aqueous, plus OH-, which is aqueous, and we're going to produce water, which is a liquid. And it's going to look the same, and it's already balanced. We have 2 H's because we have one here and one here. We have 2 H's here. We have 1 oxygen here, 1 here. This side has a charge of 0, And this side, since we have a +1 and a -1, this side also has a charge of 0. So that is a complete balanced net ionic equation for this reaction.